Welcome to the Wastewater Treatment Certification Training webinar series. This presentation is Chapter 4, Preliminary Treatment, and the narrator for this is John Walker. What do we understand by preliminary treatment? This is the removal of anything that is usually untreatable from the waste stream before it goes into the wastewater plant. It's important for a number of reasons. One is that it's untreatable and could block the system. The inorganic objects we might find might damage pumps and valves, clog pumps and valves, and so if we can remove these before it gets into the plant will operate much better. There are various treatment options we can use. These are listed on the slide. We can screen objects out through a screening process using a physical sieve, if you like. Grit removal for anything like sand or silt, coffee grounds, nutshells that are heavier than water that can settle out very quickly. For things that are rather large, we can grind them up. We call that process comminution. And also we could have a storage facility or multiple basins that we can equalize the flow in so things can be settled out or like fats and greases skimmed off the top. So screening, this is probably very familiar to virtually anybody who works in a wastewater plant. As the wastewater comes in, anything large gets caught. You can see here some bars, and you can see here the waste that's been caught in the water coming through. Of course, you're going to have to clean this. There are many different ways that we can do this. We can have bars like this. We can have a wire mesh. Next couple of slides will show some things that we might encounter. But before we go on to that, I just want to show you what happens when water coming into a plant hits a bar screen or a sieve or some way to collect material that we want to remove. Here's the bar, here's the water coming in. Notice how higher the level is on this side of the bar screen than the other. This is due to stuff that might accumulate, but it's also the fact that the water flow here has to get through the holes in the bar screen or the sieve or whatever, so the water level is going to be higher upstream of the screening process. Here's a couple of examples. Here's a very straightforward bar screen. Here is one that's on a escalator type piece of machinery. Here you can see bits of rock and other pieces that have been collected, and then as this goes around, it gets dumped automatically into a container and gets carted away. Here is another example of rotating screen. As the water comes in, water can flow out, but anything is collected in here and can be disposed of. Here is a very fine mesh. We call this a hydrosieve. And again, it was collect a lot of very fine particles and other things that normally get flushed down the toilet or get in the system that shouldn't be there. Some of the issues with having a screen that may affect the rest of the process, as the amount of pressure through the screen will be reduced as the screen gets clogged up. So this is why screens are either automatically cleaned or manually cleaned on a regular basis, because as we saw in that slide with a higher level of water before the screen, you want to reduce that as much as you can. If you don't have a self-cleaning screening system, then the operator is going to get a little messy and dirty. Again, if you're going to use fine screens, then it might be important for you to remove as much as you can oils and greases that should be removed early on. Hopefully your facility or your municipality has an oil and grease ordinance, fats, oil and grease ordinance. So even though some of it might get through, these will be significantly reduced. Grit removal was the second part of preliminary treatment. So this is taken from the manual. I've put it in italics. I'm not going to read it verbatim. You can do that if you want to. But the idea of grit removal is to remove solid material that is heavier than the water and then will sink to the bottom. Notice the words here: organic putrescible solids. Putrescible is a fancy word meaning can be broken down by bacteria, and it also often implies that that process might not smell that good. The things that are usually removed in a grit removal system, of course, we have our inorganic material, sand, gravel, silt, cinders if you've got coal fires, and organic material, eggshells, seeds, coffee grounds, bone chips, anything else that you might flush down the sink that doesn't get caught in your home sort of grinder in your system. The reason we want to remove grit is because grit can wear things like pumps, valves, other parts of the system if it gets through there. Here is an example of a wheelbarrow or a bucket that contains a lot of grit that has been removed from the system. There are various types of grit chambers, those that are just a horizontal flow and depend on the slowing down of the water flow for grit to settle out, or you can be expensive and use a lot of power, as in an aerated or vortex type system of grit removal. Here is an example of a horizontal channel. As water flows down this channel, things will settle out because the velocity will be lowered to maybe less than 1.5 feet per second. You don't want it too lower than that because nothing will get into your plant. The grit settles out and can be removed later. Everything else remains in suspension. An aerated grit chamber, again, here is your inflow of your material, and as you pump air through this, it forces the solution, the wastewater, to move in this direction in a helical way, and anything heavy will just settle out and everything light will be maintained in suspension and leave over this weir here at the end of the chamber. You can use something that looks like this. This is a vortex. This is very similar to the aerated grit chamber, but it's upright rather than laying flat. And again, as water comes through here, anything solid will sort of settle in the bottom of the tank here, and all other suspended material will leave and go into the wastewater plant. Grit, if you collect it before you dump it, it's probably good to wash it, because things stick to each other, and any organic material that sticks to grit will ultimately probably be decomposed by bacteria. Remember, I mentioned the word putrescible earlier, and the result of that is the smell, and people living near your plant may not be very happy with odors that are a nuisance to them. The organic matter can be returned to the wastewater and help feed the plant. The third way of getting rid of material you don't want to get into the wastewater treatment system is grinders, or what we call comminutors. And there are lots of videos out there. I think one's called a muffin monster. You can just check it out on YouTube. You can throw all sorts of things in there and it will just chew it up into very, very small pieces. They can grind things up, but they don't necessarily remove everything from the flow stream. Can be used by smaller community plants to remove large items from the process. Here is an example of it. Here's the cutting heads, and as they revolve at high speed, everything large is broken up and can be treated later. If it doesn't seem to work well, it's because grit has got into the system maybe and has dulled the cutters. So you might need to do regular maintenance on these machines if you have them. And sometimes the cutters don't get adjusted correctly and are not taking care of the large pieces of matter that's coming through as well as they should. So again, if things are coming through, you might want to sharpen or adjust the cutters on the comminutor, and it will do its job. The other way that we can help removing excess material coming into the plant, this is often more of dealing with the amount of water coming in, is to have multiple basins where you can take in changes in the amount of water coming into the plant, store it in separate basins, and then you can remove at a more constant rate into the secondary and tertiary treatment parts of the plant. Again, if you know that you've got a contaminated load that changes, you can sort of remove the adverse effects of those by sharing it between different basins. And of course, there's different ways in which they can be put into the plant in a series or in parallel, or a combination of those. The good thing about flow equalization is you can operate your plant in a much more stable way. Because it's a basin, you can add more aeration capacity, which will start the treatment process earlier. And if you're going to keep things a long time, you probably do need aeration to prevent the wastewater that's sitting in there becoming anaerobic or septic and then smelling. Here is a couple of equalization basins. As the water comes in, it can be split either into this one or to this one, and then water can be taken out to treat based on the levels that are in each of them. That concludes Chapter 4, preliminary treatment. And again, as we do every time, we give you 2 ways to contact us, either by email at envhelp@ky.gov or by phone 502-782-6189. So if you have any comments or questions on material that was covered in this presentation, please contact us and we will do our very best to help you understand or clear up any confusions. Thank you very much.